welcome to Scattergraphs with Qubit Education. In this lecture you will name the different types of correlation, interpret scattergraphs and answer exam questions and draw a scattergraph using given data. So first of all then let's have a look at correlation. So correlation means that there is a relationship between two variables. You can either have a positive correlation where both increase, so the height and weight both increase. As one goes up the other goes up. A negative correlation is where as one goes up, the other goes down. So as the amount of rainfall increases, the amount of sunshine decreases. And you can have no correlation, which is where there is no link between the two. So here, amount earned and height. Okay. So some more examples then. A positive correlation, as I said, as one goes up, the other goes down. So we could have the amount of water used would go up if the number of people in the household went up. I think I made a mistake there. As one goes up, the other goes up. Just want to make sure that's clear. That's a positive correlation. For example, the buckets of popcorn sold at a cinema and the number of people going to the cinema would obviously both increase. Number of deaths from lung cancer and the number of cigarettes sold. And the number of TV licenses sold and the number of sets of TV sold. A negative correlation is where one goes up, the other goes down. So the number of fish in a river and the amount of pollution in a river. So as the pollution goes down, the fish go up. As journey time home goes up, the speed of the car, the journey time home will go up as the speed of the car slows down, because it will take you longer. The number of burglaries would go up if the number of policemen patrolling in the area went down, and the number of tea left in a cup would go up as the amount of tea drunk from the cup went down. Okay, oops. So then no correlation. Average height of the population of a country would have no link at all to the amount of rainfall. The number of marks in a maths homework would have no correlation or link between the distance the pupil lived from school. So not many on that front, but here make sure you understand the two here. Okay, so let's have a look at an example of a scattergraph. 10 pupils took 2 examination papers in maths. Their marks out of 50 were recorded. So here we've got a graph that is going to show us paper 1 and paper 2. Now I'm just going to mention before I go through this that you can see here I've used a scale. So this has gone up in tens and so has this. And you can see here we've got some numbers going from 20 all the way up to in their 40s. So we need a nice clear scale. So paper 1 scores 44 and paper 2 scores 43. So we would go over to 44 and then we would go up to 43 and we'll place our mark. And the same as follows, we'd go across to 24 and up to 28, across to 40 and up to 38 and so on, and we'll plot all of our points on the graph. So already you've scored some marks doing that. Question B says, what does the scattergraph tell you about the connection between the marks on paper 1 and the marks on paper 2? Well, you might have noticed that there's a positive correlation. The pupils with higher marks on paper 1 tend to get higher marks on paper 2. Question C asks us to draw the line of best fit. So, this line of best fit looks kind of okay, but it's not perfect. You want to try and get as many dots as you can on either side of the line. And it needs to go parallel to the line. So obviously, this line of best fit is also wrong. This one is the best we've got here. You're trying to get as many either side as equal as you can, and you're going directly parallel to the line. Question D says, Charlie was absent for paper 2. She scored 32 marks on paper 1. Use the scattergraph and your line of best fit to give her a fair mark on paper 2. So paper 1, she scored 32 marks. So we need to go along to 32 at the bottom of the scattergraph that represents paper 1. We then go up to the line, and when we reach the line of best fit, we go across to the paper 2 axis. And as you can see, that is telling us 34. So we could say that she probably would have scored about 34 marks on paper 2. And finally, question E says that Peter missed paper 1. He scored 20 marks on paper 2. Estimate the mark he may have got on paper 1. So on paper 2, we need to go up to 20 on paper 2, which is here. We go across to the line of best fit and down to where it would say paper 1, giving us an answer of 11 marks. But question F says, which of your answers to D and E are more reliable? Explain your answer, including definitions for interpolation and extrapolation. Now that's a difficult question, But really what it's saying is you've got a mark here that is giving us an answer based on our line of best fit that is directly in line with all of this data. Whereas here, this answer is completely out of the way. We've got no data whatsoever, so we're actually just guessing. So this is the most reliable section of data. We can say that our estimate in the region are reliable here, as the data we have used has these boundaries. Estimates from here are interpolated. That means we've used data that we already know to get our answer. However, estimates outside of this region are unreliable, as we don't know if the relationship continues to work, as we haven't got actual data here. Estimates from here are extrapolated data, meaning we haven't actually used the data that we have, we've just extended our line. So it could be completely wrong and misinterpreted. Charlie's mark is interpolated, so is reliable. Peter's mark is extrapolated, so is unreliable. So those are your answers. Try to take some really good notes here because these are easy marks. You've just got to remember exactly what the examiner wants you to say. Okay, let's have a look at another question. Each week during the summer season, a seaside resort recorded the rainfall and the number of deck chair tickets sold. The results are shown in the table. So as you can see, I've drawn a scatter graph. Well, not me, this is from an exam paper. So there's a scatter graph here with a nice, neat axis here for the deck chair tickets. Deck chair tickets sold was quite high, with as high as 610 tickets sold. So as you can see, they've gone up in a nice axis of 100. Okay, nice. Trying to think of the word, I used it earlier. So it's gone up in 100 units. Thank you. It's gone up in nice, easy units of 100. Sorry, I don't know why I couldn't remember that word. Okay, and then across the bottom we can see that the rainfall is actually a lot smaller numbers because they're measured in millimetres. So it's gone up in an axis using units of 5. So 5, 10, 15, 20, etc. And it says rain in millimetres. This one says deck chair tickets. So now I'm going to go across to 17 on the x-axis at the bottom. Okay, here. Actually, I think that's 16, so 17 there. And up to 320 here. So, and then I'll plot my point. And again for the rest of the points. Okay. So then, question B says, what does the scatter graph tell you about the connection between the rainfall and the number of deck chair tickets sold? Well, you could already assume that if it's not raining, you can go to the beach or, it's sunny. So we would assume that if there's less rainfall, then more deck chair tickets are sold, which we can see in the graph. So it's a negative correlation. As the rainfall increases, deck chair sales decrease. Okay, so now it asks you to draw a line of best fit. Again, incorrect. We need to try and get as equal as possible. So, that looks okay. Let's try one more. Yep. Okay, so we've tried to get an equal amount of points-ish, either side or in the middle of the line, which looks nice. D says, in the first week of June, only 250 deck chair tickets were sold. How much rain do you think the resort had that week? So it's telling us that 250 deck chair tickets were sold. So we need to go up to the 250 mark on our graph and go along to the line of best fit. We then go straight down to the amount of rainfall, and it's on 24. So we can estimate that there were 24 millimetres of rainfall that week. Question 5 says, in the second week of June, there was 5 millimetres of rain all week. Estimate the number of deck chair tickets sold that month. So, 5 millimetres of rainfall all week, there. We go up and across, and it tells us that there were 570 deck chair tickets sold. But question F says, how reliable are your estimates for D and E? Explain your answer. Well, we can say that this is our most reliable section of data just there. Estimates are reliable in this region, so we can say that it is interpolation, or the data that you use is interpolated. 250 deck chairs equals 24 millimetres of rain, which is extrapolation, which is unreliable, because here we're using data that's outside of that region, whereas the 5 millimetres of rain for question E meant that 570 deck chairs were sold. This is interpolation because we used this section of the graph, which means it's reliable. Okay, so you have named different types of correlation, you've interpreted scatter graphs and answered some exam questions, and based on the fact that I've shown you how to draw those graphs as well, you should be able to draw a scatter graph using given data now. So well done, thank you very much for using Cuba Education, and I hope to see you next time.